Welcome to our presentation on comparative analysis of machine learning algorithms for laptop value estimation. My name is Vincentius Axelle Tanoto from the School of Computer Science, Bina Nusantara University, along with Ken Christopher Hansel, also from the School of Computer Science, Bina Nusantara University. Muhamad Fajar and Putri Andam are our supervising lecturers for this research project. Our research structure includes the following sections: introduction, literature review, research methodology, results and discussion, and conclusion. Now let's dive into the world of laptop price prediction. Firstly, laptops have become an integral part of our daily lives. They are now commonplace in homes, schools, workplaces, and businesses. With technological advancements, the demand for laptops continues to grow. More and more people are relying on them for their everyday tasks, making them essential tools in modern society. The purpose of this study is to predict laptop prices based on their specifications using advanced machine learning techniques. This helps us understand the factors that influence laptop pricing and make accurate predictions. Accurate price prediction is crucial for consumers. It helps buyers avoid overpaying for laptops with poor specification, ensuring they get the best value for their money. Our goal is to identify the most accurate model for predicting laptop prices. By doing so, we aim to assist buyers in making informed decisions and choosing the best laptops that meet their needs and budget. Now let's take a look at the related works in the field of laptop price prediction and how they inform our study. In a study by Lokmane Akou, several models were tested for laptop price prediction, including linear regression, elastic net, and gradient boosting regressor. The gradient boosting regressor stood out, achieving the highest R-squared score of 0.88 and the lowest mean squared error of 0.05. Another study focused on predicting quality changes in spreadable Gouda cheese during storage using artificial neural network and MLR. The artificial neural network model outperformed MLR, demonstrating higher R-squared values and lower RMSE, indicating better predictive accuracy. Now, I will hand it over to Ken, who will elaborate on our research methodology and results.
Thank you, Axel. Now I will dwell into the research methodology employed in our experiment. The experiment was conducted through four major steps: data collection and preprocessing, model building and training, model testing, and prediction accuracy evaluation or model evaluation. For the data collection and preprocessing, the data was collected from a public repository containing laptop prices and laptop specifications with 7 features and 1,000 instances of data. Data cleaning was not required, for the dataset is free of missing values and outliers. The brand feature was encoded to a suitable format from string to float, and then the data was normalized using the min-max normalization to ensure the balance and minimize the variance of the data. Because all the features of the dataset was deemed significant, so no specific features were selected and none were removed. Lastly, data was split with a 70 to 30% ratio, 70% for training set and 30% testing set for model training and evaluation. The table displayed on the side lists the features of our dataset. The features include brand, a string representing the laptop manufacturer, processor speed, a float representing the processor speed of the laptop, RAM size, an integer denoting the RAM capacity, storage capacity, an integer indicating the storage capacity, screen size, a float representing the screen size, weight, a float indicating the weight of the laptop, and price, the target variable represented as a float denoting the price of the laptop. For the model building, the sklearn library was used to build the models for its comprehensive tools and also efficiency. We constructed four models for this experiment: an artificial neural network or ANN, multiple linear regression or MLR, support vector regressor or SVR, and random forest RF algorithm. The artificial neural network model was configured with two hidden layers, each containing 50 neurons with the Adam optimizer for weight optimization. The multiple linear regression model was implemented using linear regression model from sklearn linear model library. The support factor regression model was implemented using the SVR model from Axelle SVM library with the radial basis function or RBF kernel. And lastly, the random forest model was implemented using the random forest regressor from Axelle Ensemble, configured with 100 estimators and a specified random state for reproducibility. After training the models, we tested them using 30% of the preprocessed dataset. The predicted prices were then compared to the actual prices. We employed several evaluation techniques, including mean absolute error or MAE, mean absolute percentage error or MAPE, root mean square error or RMSE, and the coefficient of determination or R squared. The objective of our model evaluation were to assess the accuracy and reliability of the predictions. A lower MAE, MAPE, and RMSE indicate higher accuracy of the model, and conversely, a higher R-square score indicates a better fit of the model to the data. These metrics enabled us to determine the best algorithm for predicting laptop prices based on the performance of each model. Performance comparison revealed no significant differences in prediction accuracy among the algorithms. However, the support factor machine exhibitedly showed a slightly higher root mean square error of 0.09 compared to 0.07 for the artificial neural network and 0.02 for both the multiple linear regression and random forest models. The best performing models were the multiple linear regression and random forest. Both models achieved an R square value of 1, indicating a perfect fit to the data. They also had the lowest RMSE and MAE values, both at 0.02, highlighting their superior accuracy in predicting laptop prices. Among these two top performing models, the MLR had an additional advantage of a lower MAPE score compared to the RF model. In conclusion, the multiple linear regression and random forest models provide the most accurate and reliable predictions for laptop prices based on our dataset. Displayed here are the plotting figures comparing the predicted values to the actual values. The red line indicates a perfect prediction, with the x-axis representing actual values and the y-axis representing predicted values. The blue dots scatter between the predicted and actual values, illustrating the model's performance. From these figures, it is evident that the multiple linear regression and random forest models exhibit the best performance with higher accuracy. These models not only provide more precise predictions, but also benefit from simpler architecture and faster runtimes. MLR and RF particularly excel in scenarios where a linear relationship exists among the features, contributing to the superior result. Now I'm going to pass it back to Axelle.
Finally, let's move on to the conclusion of our study on laptop price prediction using machine learning. Our research focused on a comparative analysis of multiple linear regression, artificial neural network, random forest, and support factor regression for predicting laptop prices. Among the model tested, multiple linear regression and random forest emerged as the best performing models, each achieving the lowest RMSE score of 0.02. This indicates their high accuracy in predicting laptop prices. Contrary to previous studies that often favored artificial neural network as the optimal regressor, our findings showed that multiple linear regression and random forests were more effective in this context, highlighting the importance of context-specific model selection. Although artificial neural network and SVR did not perform as well in our study, they still hold potential. With different datasets or further optimization, these models could excel in laptop price prediction. Future research should explore incorporating nonlinear factors such as brand reputation or advanced technologies and utilize feature engineering techniques to improve prediction accuracy. The key insight from our study is the importance of aligning predictive models with the characteristics of the dataset. Doing so can significantly enhance the accuracy and robustness of the prediction across various contexts. Thank you for your attention and for joining us on this research journey. We hope our findings contribute to advancing the field of laptop price prediction and assist future studies in developing more accurate and reliable models.